Perfect. So thank you very much for the introduction. So as it was stated before, I will be presenting some of the work I've been doing with people at Northwestern University Libraries on some arsenical bindings. And so I will present mostly the analytical aspect of it with some of the implication that I had some of the implication of finding those arsenical bindings. So first I wanted to start with a few words on the type of collections we are all working with. And so I think when thinking of the collections in libraries and archives where most of the documents are fully available or sometimes upon request to the general public, there's little to no restrictions. You can just browse them. Sometimes you can even bring them back home. And so the problematics that are related to those objects are very different from what you can find in galleries or a museum, which is what I was used to do before working on this project and joining the National Archives in the UK afterwards. And so I think when dealing with library and archives collection, there are the so-called problematic materials. And so I think we've all encountered some of those. And so they can be, for example, mold affected items. And I'm not going to be talking about that today, but I've seen a few after I joined the National Archives. Then there's also other types of materials like the insecticide treated documents. And again, I'm not going to be talking about that today, but Laura Angelova is going to be giving a presentation about that in session 3. And then another type of document that may be seen as problematic might be the documents with hazardous pigments or additives, such as arsenic sulfide, arsenic oxide, emerald green, either used as pigments or as ways of treating the materials. And this is what I'm going to be talking about today. So here I'm presenting some of the examples that we've had in National Archives, but as I said before, I'm going to be talking about the research I've done while I was at NU Access at Northwestern University with in collaboration with Northwestern University Libraries. So what we then called the Poison Book Project, and I believe we're not supposed to call it this way anymore, but that's kind of how that was brought to us, is kind of a follow-up project that was built upon the Winterthur project, of which we're all very aware of, and that has spread in National Bureaugraphic. And so when Carissa joined Northwestern University Libraries, she decided, along with Susan, to send us at NU Access a request for a project to kind of continue the research on Greek book bindings from the 19th century. And so the idea with that was to kind of follow up on what was done at Winterthur, but with a broader dating of the materials, and also increase the type of materials that were used, like not necessarily focusing on the textile, but looking at paper, and as well like paper cover, and as well decorated page edges. We also wanted to broaden the geographic origin of those books by including books from France, Germany, Austria, and Italy, include more colors than the vibrant green. But one of the main interest of doing that at Northwestern was also the big corpus of green books that potentially contained copper and arsenic, because Northwestern has more than 6 million titles, and 5,000 of them are green books that may potentially contain arsenic and copper. And so we had a much broader scope that allowed to get a very nice statistical approach to the presence of those materials in the collection, and therefore gain a better understanding of the production of those books in the 19th century. So as it was at Winterthur and many other places, we started with a non-invasive approach using XRF. So we did an XRF survey of the books, and so we were able first to see kind of three major patterns in the XRF reading. One was, I don't know if you see my cursor, but one has like basically a 1-to-1 copper to arsenic ratio. One had, like, another group had a 2-to-1 copper to arsenic ratio, and the other group was mostly copper and almost no arsenic in it. So that allowed to kind of create first like some groupings that could indicate what type of ink were used. And hopefully using the color of those books, we were hoping to be able to kind of do a first assessment. However, when we looked at the color of the books associated with different ratios, we saw that the color is not a good enough discriminant factor to figure out if we have indeed a copper and arsenic containing book or not. So following the XRF survey, we wanted to know a bit more about the type of pigments that was used, if it was Scheele's green or emerald green, what was the source of the 2-to-1 and 1-to-1 ratio. And so we did some ATR, FTIR, and Raman, which allowed us to identify emerald green in all of the books that we analyzed. And we also wanted to see if we were able to identify degradation products in areas just like the spine over here that clearly appeared of a different color. And so this approach allowed us to identify potentially hazardous books, making some groupings based on the ratio in XRF, and allowed to identify emerald green in all of the cases that we analyzed, as well as copper hydroxide in the case of the 2-to-1 copper to arsenic ratio. So that gave us the first information about maybe the process that was used to create the color, like the pigment or the color of the book. However, I was very annoyed not being able to see degradation products on the spine and other places of the books. But having worked on arsenic-based pigments before during my PhD, I knew that FTIR was somehow not the best technique to see arsenic oxide and arsenate. And I published that in a few years ago, and you can see that only big amounts of arsenate will allow to see, will be allowed to be identified. However, if we move to synchrotron radiation, looking at oxidation state of the element, we were able to identify the oxidation product and the degradation product in, at that point, paint microsamples. And so having that in mind and having some contacts at the synchrotron, we decided to do the same thing for the books. So we sent some books and some samples to the synchrotron in Stanford, and we looked at possible degradation products and their distribution within the object. And so we have here the case of the book that has the discolored spine. And so you can see at the top of her, like the top of the three images is the reduced form of the arsenic, so the non-degraded pigment. The middle image is the oxidized form, so the degradation product of the pigment. And the bottom one is just the two overlaid to see exactly their distribution. And so you can see that this technique allowed us to clearly see that the spine is oxidized and therefore degraded, which is a good indication that something happened which seems to be related to either oxygen, like being in the contact with the oxygen, or light, because the cover, which is covered with other books, is not affected as much. But we also looked at the page edges. And so you can see, like in the case of the page edges, we have also the same kind of images with the reduced, so the non-degraded pigment located at the edge, which does make sense with the green still being present. But then when we looked at the oxidized forms, we can see that you have a lot of oxidized pigment, so like the degradation product, at the edges of the book, which does make sense. But you also have a clear a gradient going inside the page, which shows that there's probably a migration of the oxidized form within the page due to possibly moisture within the air that will kind of move those very mobile form within the paper itself, which shows that it's not located only at the edge, but also further inside the paper. And so that can be also an issue when kind of turning the pages, even if we want to avoid the grain that is on the edges. And so having done that, we also wanted to look at what happens when the books are being in contact for a long period of time or are being rubbed against one another. And so we were interested in the possible mobility of transfer to non-green books. And so for that, what we did, we did the same kind of experiment at the synchrotron on books that were not green, but have been stored for a long period of time next to a green book. And so what we saw is that the book that is not green does indeed contain some traces of arsenic and copper, which means that there is a transfer of a pigment or degraded form of the pigment onto the non-green book, making it somehow contaminated. And so when we looked at the oxidation states, we saw that we have both non-degraded pigment and degradation products, which shows that either the non-degraded pigment oxidized onto the new book, or there is transfer of both forms onto the non-green book. And so that shows also that we are putting the focus on the green books, but probably most of the books that are not green but have been stored next to those emerald green or Chiles green containing books may also be somehow contaminated as well, which are therefore also an issue for the health and safety of the staff at the library and the users if they take the books home with them. And so what to do in that case? And so I'm pretty sure that Carissa and Suzanne will talk more in depth about that, but I just wanted to kind of talk a little bit about it. And so first, obviously, when we identified books that contain arsenic and copper, the access was taken away. We took them off of they took them off of the shelves. Once they we also put them, we isolated them into plastic bags, Ziploc bags, which I believe is more of a temporary thing than a long-term alternative, because the environment within the closed environment within the Ziploc bag might actually also kind of auto-catalyze the degradation of the oxidation of the pigment. There's also obviously health and safety measures that were taken with safe handling, PPE, user agreement, and controlled environment in which the books could be looked at and read. And then the second step was to do risk assessment. And so we can see here Suzanne doing air monitoring, particles and VOCs, as well as looking at the dermal transfer to determine the risks of handling those books. And then one thing that we have been talking about was to also look at different methods of cleaning the items, and especially the one that have been contaminated because of the prolonged contact. And this is a future research that we want to put in and clean different areas of the same book with different type of cleaning methods, and then send the book back to the synchrotron and see which one is the best suited or has the best results in order to decontaminate, if I may say so, the contaminated books. And obviously one of the other options is digitization, which would allow an access to the public with no associated risks, but this is a very lengthy and expensive process, and so it may not be possible to do that for everything. And I'm just finishing with a conclusive remark, and I think I'm at the end of my 10 minutes. And so we've noticed that through this study, we've noticed that emerald green is prevalent in 19th century books. We've also seen that the color is not a good enough indication of what is actually being used in the book. And so we need to do chemical analysis, mostly using XRF as a first tool to figure out what it is. We were also able to identify degradation products and transfer to non-green books, which also increased the risks to the users. And there's much more research to be done, and that I think that will be very well presented during this symposium. But it's also, I think this kind of also opened the Pandora box, because we're looking at arsenic and copper containing books, but what about lead, mercury, or chromium containing books? And I think this is going to be talked about in session number 2. And on those, I'd like to thank all of you, and I'd like to thank all of my co-workers on this study, as well as the Mellon Foundation for funding it. Thank you very much.